Hey everybody, welcome to the last video of part A on square roots and the Pythagorean theorem. After this video, we will start to talk about the Pythagorean theorem itself, but today we're doing the last bit regarding square roots, and it's going to be about area versus side. You'll find this one very quick and very easy because we've already talked a lot about these two topics in the past, just little tidbits along the way, so it shouldn't be anything too surprisingly new, but it's kind of the same stuff in practice. That being said, let's get started. 25 squared. If we were to answer that, we would recognize that 25 squared means the same thing as 25 times 25. So it shouldn't surprise you that it becomes 625 units squared. So if this is like centimeters, 25 centimeters times 25 centimeters, it's 625 centimeters squared. Okay? What is the square root of 25? Square root, remember, is the opposite operation, so it's everything in reverse. So if we had 625 squared, or 625, and we did the square root of that, it would give us 25. Squaring 25 gets us 625, and square rooting 625 gets us 25. So, what is the square root of 25? Well, what squared makes 25? You can think about it that way. What squared makes 25? Something times itself making 25. Well, you should be able to answer that that is 5. 5 times 5 is 25. So if I do the square root of 25, then it would be 5. Okay? All right. I don't think that should have been too hard, so let's just jump right in with a show you know. I want you to determine the area of a square that has a side length of 16 millimeters. So remember, we have a square, and the area inside of that square is unknown, but we do know that the side length is 16. So if one side of a square is 16, all sides of a square are 16. So determine the area of that interior part. Pause the video. Shouldn't take you very long, but pause the video and get that answer. Okay, here's what I got. I made my square here, 16 millimeters on each. Remember, the units do have to be included, so if you just wrote 96, you have an incomplete answer. Make sure you put the units as well. So I'm trying to find the area inside. So the area of a square is length times width. 16 times 16 is 16 squared, which is 96 millimeters squared. Okay, next one. Determine the side length of a square with an area of 196. So it's kind of like that other one, except this time we're saying the inside, the area, is 196 centimeters squared, and you're trying to find all the side lengths of the square. So we're doing the same thing in reverse. Hint, hint, if you squared something to get the area, and you have the area, you could probably square root the area to get the side. Try that out and pause the video. All right, here's what I got. I broke it down just to make it easier so I didn't have to use a calculator here. 196 was my area, and I divide by 2, oh, excuse me, and then 7 and 7. So I have a set of 2's and another set of 7's, and that means it is a perfect square, and the perfect square of 14. And if I had my perfect squares memorized, I would have just been able to shortcut that, but I don't, so I need to have a little more work here. So 2 squared and 7 squared are going to cancel out, and I get 14 centimeters. So that means all these lengths of this square that have an interior of 196 centimeters square as an area, all the side lengths are 14 centimeters. All right. Determine the area of the picture frame. So not the picture itself, not the tree, but the actual frame. This is not a show you know. This is something we're going to work on together. So we know that the side length is 13, and it is a square because it's showing us that it's 13 and 13. So the area of the picture frame, well, the area, oh, I didn't know it was going to be green. Okay, the area is 13 times 13 centimeters. I should write that, but I'm out of space. So that's the same as 13 centimeters squared. And I'll plug it into the calculator here for you. 13 times 13 happens to be 169 centimeters squared, because I just squared those numbers. So the area is 169 centimeters squared of the entire picture frame. So that includes all this right here. Okay, except for the part that's outside of the picture frame, which I will now erase because I don't want to confuse you and send imaginary lines out to the middle of nowhere. All right, so all this interior stuff, that is all included. Okay, determine the width of the picture frame. The picture frame, interesting. What are we going to do here? So we know that this length is 11. And well, I guess we could... I'm a little confused here. Why would we be trying to find the width of the picture frame when we already have the width of the picture frame? Huh? What kind of a question is this? The width is 13 centimeters. So what was originally trying to be asked here? We were trying... Wow. All right. Let's ignore this question because clearly it is dumb. And instead, I'm going to change it right here on the fly and create something else. I'm going to cross this off. It never existed. And I'm going to say that the interior of this area right here of the picture itself... oh, actually, I want that. Determine the width of the picture, and the picture itself, I need a new color. The picture itself has an internal area of, let's do 121 centimeters squared. All right, now we can do something. And you probably already know the answer. All right. Determine the width of the picture frame. I'm going to do the square root of 121 because I know that this is the area. So if I do the square root of the area, it's going to give me the side length. So the side length of the square root of 121 is just, well, let's see. I do have that square memorized because it's a fairly common one. It's 11 squared. So my answer is 11. The side length is 11. So that means that this is 11, this is 11, this is 11, this is an 11. Here's an 11 for you, an 11 for you. Everybody has an 11. Last question. I thought we were done. What question could you write for this diagram? Oh yeah, we are kind of done. We just have to talk about this one. So, unlike that terrible question that I just had on the previous slide, let's see if we can create a better one here. Well, the internal area of the inside piece here is 121 centimeters squared. So I could ask a question for sure. That is to determine the side lengths. Okay, cool. I have the internal area of this whole thing. And I could, ask a question to find the side lengths. But the really cool thing I could do, because I have an area inside of an area, is I could actually try to find the area of, oh, wait a minute. Is this 196 including the 121? I think it is. I think that this 196 centimeters squared is all of this. Okay? So assuming that this 196 is all of that, and then the 121 is this, the cool kind of question I could ask is figure out the area of just this part right here. And it's not that it's super challenging, it just makes it a little more fun. So the easy way to do it would just be to subtract, but I would probably change this 121 to be 11. And then that makes a little more work for you because you have to figure out what the area is here and then, work out things here. Or I could also say, well, what's 196? 196, the square root of that is what? That's something I should have memorized too. Why don't I have all these things memorized? Square root of 196 is 14. I feel like I just did that in a previous example. So the square root of that is 14. So the cool thing I could do to make this a nice question is say that's a side length of 11, and this is 11. These are all squares. This is 14, and this is 14. So tell me the area of the shaded yellow region. That's the kind of question I would ask you. That seems like a fun, challenging question. And you probably don't agree with me at all. That probably looks crazy to you. Okay, that's all for this video. 11 minutes, that's not too bad. And that is the end of part A. Pythagorean theorem should be a little better because we are going to, well, the nice thing about Pythagorean theorem is it's a lot more practical. It's stuff that you are going to be applying rather than too much talk about just what things are. You're just going to be doing it for the most part. And Pythagorean theorem is very applicable in all parts of life. I mean, it's necessary to understand how to do just construction, farming. It's used in basically everything that uses right angles and triangles and squares. It's so important, and it's very important for you to learn it very well. All right, see you in the next one.